So the lesson 3.5, you will notice the first page says solving equations using logarithm properties. As you look down at these examples, you'll notice there are multiple logs in all of these examples. And that's the difference between the first page and the second page. The second page doesn't really have logs in them. The first page does. So there's kind of listed as 3 steps up there. It's kind of 3 suggested steps. But if there are logs on both sides, our first step job is going to be to write both sides as 1 log on each side. If you can get it to the point where you have 1 log on each side, then we can set the insides equal to each other, and then we'll be able to solve. That part's, generally speaking, going to be the easier part. The key is how we get it to have 1 log on each side. And that's where our properties from yesterday are going to come into play. Calculator for second page. You won't need it for this page. It's pretty basic stuff on this page.
Is this where you can use the product rule?
Mm-hmm. Yeah, so as we look at example 1, log base b of 5 plus log base b of 4 minus log base b of 2 equals log base b of x. Step 1 is you want to get this to the point where we have 1 log on each side. So you know yesterday and last night's homework where you had to condense some logs? That's what we're doing. We're using our product rule, quotient rule, and power rule to do some condensing. So what do you guys see on the left there that you want to do on number 1?
The log of 4 times 5. Log of 4.
Okay, so the first thing, I agree, there's 2 logs being added. Remember from yesterday, 2 logs being added can be rewritten as 1 log being multiplied. Now, depending on how much you guys will let me do, what about this subtraction here? That means that can be combined with another log. 2 logs being subtracted could be rewritten with 1 log where the insides are being divided. So what are the pieces if we put this all together as 1 log on the left?
120 divided by log
base b of 2, 10. Log base b of 10. That's 5 times 4 was 2.
Okay, so for anyone looking at the notes without, I'm writing it out kind of long way first. But the idea of the 5 and 4 being multiplied because there's 2 logs being added. The 2 is being divided because it was being subtracted. Now, by all means, clean that up. 5 times 4 divided by 2 is 10. And so this left side can be simplified to say log base b of 10. And it equals log base b of x.
So x would equal 10.
Agree? Hayden says x equals 10. The logs are both logs, and they're both base b. Now, it'd be different if they were 2 different bases. But they're both the same base. And so that means drop the log base b, and we have 10 equals x. Step 3 is normally to solve for the variable. In this case, it's done. And so x is 10 here.
Well, pretty much just 1.
That wasn't a horrible problem, right? Okay, example 2 then. 2 log base 5 of x equals 1/2 log base 5 of 144 minus log base 5 of 3. Yeah, what's she using? Power rule, or were they rules or properties? I can never remember. Power rule, power property. I keep calling them both, so you know what I mean. The power thing, right? The idea is, so here's what I am going to say. Do not try and use product or quotient rule. Like, don't use the quotient rule on that right until you have dealt with the powers. And so first thing we're going to do is we're going to take that 2 and move it, and that 1/2 and move it. So log base 5 of x squared equals log base 5 of 144 to the 1/2 minus log base 5 of 3. Now, technically, I did not write exactly what Emma said. What do we know about that 1/2 power? It's a square root, yes? And so, at your comfort, so whenever you feel ready to in steps, I'm going to clean that up now. So log base 5 of x squared. So what is the square root of 144? 12. So now it's going to be log base 5 of 12 minus log base 5 of 3. What's our next cleanup step? Yeah, quotient rule. 2 logs being subtracted can be rewritten as 1 log where the insides are divided. So log base 5 of x squared equals log base 5. I'm going to put it as 12 divided by 3, but I agree, by all means, go ahead and put it at 4 as long as you understand where that came from. So log base 5 of x squared equals log base 5 of 4 at that point. Okay. So log base 5s can drop off, and we are left with the statement, I'm going to move mine over here, x squared equals 4. Agree? How do we solve if it's x squared equals 4? We take the square root, and what is the square root of 4 in the equation setting? Plus or minus 2. Now, here's what I'm going to caution you. You need to be checking your answers today. Okay? You remember when we were trying to put logs of negative numbers into our calculator the other day? It didn't work, did it? Okay? We could not do the logs of negative numbers. And so this is where you have to be careful and consider, do both answers work here? So first of all, as I put 2, log base 5 of 2, that works, right? There's, it's a positive number, not really any issues there. What about negative 2? Does it or doesn't it work?
If you was doing it like for the square.
Okay, so what I'm going to say is you need to consider, and it's a questionable one here. If you're just talking log of negative 2, log of negative 2 does not work. However, there's that 2 out front, right? And that 2 works also as a power. Does it work now if we have that squared on there? Yes. And so in this case, we can actually say that positive and negative 2 work. Okay. And again, it's because of that negative there. So they do both work. But here's what you need to be in the habit of. Checking your negative answers. Well, I should be saying checking all answers, but specifically the negatives are the ones you might run into problems on. Okay, let's do number 3, and then we'll move over to the other page. Log base 4 of x plus 6 plus log base 4 of x equals 2. Thoughts on where to begin?
You have to, what's the, I forget what it's called. It's not foil. It's, yeah.
Okay.
Thanks.
So we're going to be using the product property here. 2 logs being added can be rewritten as 1 log where the insides are multiplied. And it is distribute. So log base 4 of, what is x times x plus 6? X squared plus 6x. Equals 2. Thoughts on where to go next? What's different about this one?
It's got a log.
Okay. Last time we had a log on either side, so once we got it, so we had a log on either side, we could just drop the logs. Here, I just have one log. So we've dealt with this before. When you have one log, how do we get this out of log equation form? No, you're thinking of change of base formula, and I don't want to use that right now. Yeah, change of base formula wouldn't get me anywhere, I don't think. We used it back in lesson 3.3 is when we first used it this year. So how do we get out of log form into a different form of the equation? I think it was 3.3.
Left side middle.
Uh-huh. Yep, left, right, middle. When you have a log only on one side, and you're kind of at a stuck point, you need to go back and think left, right, middle. Okay? So do you remember how left, right, middle works? Left is the 4 raised to the right, which is the 2, equals the middle, which is x squared plus 6x. So left, right, middle takes us from an exponential equation to a logarithmic equation to an exponential equation. So I now have 4 squared equals x squared plus 6x.
So if you subtract 6x,
I would not.
Because you take an x out.
I would not.
You take the 8 and move it to x plus 6.
Yes, except it's not an 8.
oh, it's 16.
Oh, it's 16.
It's a 16. Okay, so we're going to take that 16, 4 squared is 16, and we're going to move it to the other side because we're trying to make this equation equal to 0. Okay, when you see an x squared term, an x term, and a number term, most likely make it equal to 0. So that means I'm going to have an x squared plus a 6x. I'm going to, what'd you say? Minus 16, because we subtract the 16 over, equals 0. You guys okay with how I wrote that? Kind of flip sides as I went. Thoughts on how to solve? Factor. Can we factor into 2 parentheses, we hope? X squared breaks up into x and x. Multiplying to be negative 16, adding to be 6, is a combo of 8 and 2, plus 8 minus 2. Okay, we're not done right here. We set each part equal to 0. X plus 8 equals 0. X minus 2 equals 0. So what are my possible solutions? X equals negative 8 and 2. Okay, and we should be checking our solutions. When you put them back into the original, positive 2 is okay, right? Log of 2, 2 plus 6, we're good there. What about the negative 8? Yeah, it doesn't appear to work, does it? Because log of negative 8 or log of negative 8 plus 6 is negative 2. Okay, so my thoughts are that negative 8 doesn't work, so my only answer remaining is 2. I'll be honest, I had morning class bring up a question, and I haven't had a chance to check into it yet. They suggested that maybe negative 8 did work, because after you multiply them together, it appears to work. So I'm not 100% sure on that, but the rule of thumb I've always heard is that the negative 8 does not work. So I'll just kind of throw that in there. Again, I need to look it up because I don't know. It caught me off guard this morning. I don't know. You guys okay with that basic idea? Okay, we're going to flip to the other page. Difference on this page is that majority of these problems do not have logs on both sides. They don't even really have logs in general for the most part. So I'm going to try and get through about 3 examples on this page, hopefully. Now, I do remember doing these in Algebra 2 with you. Okay? Because the first thing I taught you on a problem like number 1 says 2 to the x equals 53. Do you remember me asking, can 2 and 53 be written with the same base? In other words, can 53 be rewritten as 2 to some power? No. If it was like, say, 32, we could, because that's 2 to the 5th, but 53 cannot. And so, if you cannot get the bases the same, which is going to be the case today, we're going to take the log of both sides. You can use log base 10 or natural log, either or. Okay? So, excuse me. With that in mind, can you get 2 and 53 to be the same base? No. So I'm going to take the log of both sides. And when I say that, I'm going to write log in front of them. So it's going to be the log of 2 to the x equals the log of 53. In this case, it doesn't matter if you use common log or natural log. If there was an e in the problem, you definitely want to use natural log. If there was a 10 in the problem, you definitely want to use common log. Okay, guys, my job is to solve for x. Any thoughts on what I can do with that x?
Put the x up front.
Power rule says we can take that x and write it out front. So now it's going to be x times the log of 2 still equals the log of 53.
If we do the bases the same, the base 10 have their bases already. So.
They are, but this is a different type. It's not going to work that way. Yes, my bases are the same, but I have an x out front. Thoughts on how to solve for x here? You said something about divide. Yeah. If it's x times log 2, how do you move the log 2 away?
Can you actually go ahead and figure out the log of 53 and the log of 2?
I would not.
No.
Hang with me here. So if it's x times log 2, I want to divide by log 2. If I divide the left by log 2, divide the right by log 2. And so in that case, we come up with x is going to be equal to whatever log 53 divided by the log of 2 is. Now, I would not leave your answer here. This is where I would go the decimal route. Now, Chandler's question was, could we go ahead earlier on and find the log of 53? I would not recommend it because is the log of 53 going to be some nice, neat decimal answer? No, it's going to be a big, long, messy decimal. So then you have to decide, okay, where do I round that big, long, messy decimal? And you don't want to round it too short to affect your answer. So easier to me is we just leave it as logs, and we'll punch it into the calculator at the end. Okay? So this is the page where you do need the calculators. What is log of 53 divided by log of 2? Okay, to 3 decimal places, 5.728.
And would we get that same answer if we did natural log?
Yes. Yep. So, whether you do a fraction bar or just division, watch the use of your parentheses. So there's my log 53 divided by log 2. To answer Chandler's question, natural log of 53 divided by natural log of 2. Same exact answer. That would have really messed me up. Thankfully, my calculator cooperated and gave me 2 identical answers. Okay, got that basic idea? Okay. Example 2 is the next place we're going. Log base 4 of 11.2 equals x. Could we do a left, right, middle here? I'll be honest. I have two totally different options of which way to go here. So I agree. That's one option, in that we can do a left, right, middle. Left, right, middle is kind of reserved when we have a log on one side only. So what does left, right, middle give us? Okay. 4 to the x equals 11.2. And now, it's a problem like the previous problem, isn't it? Can 4 and 11.2 be made the same base? No. So what do? Take the log of both sides. So the log of 4 to the x equals the log of 11.2. The power rule says we can take that x out front. So it's x times the log of 4 equals the log of 11.2. How do I solve for x?
Divide both sides by the log of 4.
Divide both sides by the log of 4. And so x is, okay, I was going to say the log of 11.2 divided by the log of 4. And then the calculator does say 1.743. What if I said we just took the long way to do that problem? I mean, it was a perfectly reasonable way. I'm not arguing it. It made perfect sense. But there happened to be a shorter way to do this problem. We had that fourth rule from yesterday.
Oh yeah, that's what I was trying to do on the
I don't remember.
That change base.
Change of base rule. What does the change of base rule say about something like this? Natural log or regular log, and it's what? The log of 11.2 divided by the log of 4. So it's the log of the insides divided by the log of the base. Isn't that exactly what we ended up doing the long way? So could you have done that if you caught it? Yeah, that's legitimate. The work I would ask you to show is, from the get-go, just go ahead and write x equals log 11.2 divided by log 4. Don't go straight to the decimals, what I'm going to tell you. Okay? So, if you happen to catch that, great. If not, I'm just pointing it out because it's good to know. Now, I will throw out there, just because I mentioned it came up in the morning class. Someone in my morning class has a Casio graphing calculator, which works totally different, and so he's on his own. He's figuring it out on his own as he goes. He found the place on the Casio calculator where you can put in a log of any base, and that's an option on the Casio. Okay? Now, my response to that was, you still have to be able to show me the work. Okay? You still have to be able to either show me this method or this method. I don't want just a decimal answer without the appropriate steps. I haven't shared it with you, but it is possible on the TI. I will tell you that. Okay? So, that can be part of your homework. You'll search and play around and look for it. I know. I kept waiting for someone to bring it up. So, as I said, someone brought it up on the Casio this morning. Now, in our remaining 9 minutes, I want to look at number 4. So if you would, please, don't get too involved on the calculators now that I've said that. And let's look at number 4, please. It's important. Okay? Number 4 is definitely a little bit more on the difficult side. And I am going to make the comment, when you first start a problem like number 4, you will see some in homework that have E terms like this. But then sometimes they will have like a number in front of them or a number added on. And I'm going to tell you that your first step needs to be to make sure that your E term is isolated. So when I say isolated, I'm talking that, when I say isolate your E term, I'm saying I want your E to be by itself. So it's E to some power, meaning I don't want it to be 5E to some power. I don't want it to be E to some power and then plus 7 at the end. But make that your first step to get the E by itself. In this case, do I have E to some power by itself? I do in this case. Base E and base 5. Am I going to get those to be the same? No. So what do? We take the log of both sides. Which type log should I use? Natural log. There's an importance to using the natural log here. So we're going to use the natural log of e to the 2x. Please be on number 4 with me. Equals the natural log of 5 to the 3x minus 1. And this is where there's a definite advantage to taking the natural log. There's something special that happens on that left side if you remember all your rules. Yeah, because natural log is base e, and the inside has a base of e. Natural log base e of e to the 2x is just equivalent to 2x, that power of 2x. So this problem really becomes 2x equals the natural log of 5 to the 3x minus 1. I would not. That's just going to take you right back to the beginning. Okay. If you do left, right, and middle right now, you're going straight back to the beginning where we just came from. No. We need to more solve it of, we have an x here, we have an x here, right? What can we do with that 3x minus 1? What? Yeah. We're going to use the power rule and pull that 3x minus 1 out front. So I still have 2x. Because 3x minus 1 is more than one thing, I'm putting it in parentheses. So it's 3x minus 1 in parentheses times the natural log of 5. I have something outside the parentheses and I have parentheses. Guesses on what to do? Well, right now I still have x's on opposite sides. I wouldn't divide right now. How about take that natural log of 5 and distribute it? Because we have to get that x term so we can get the x's together on one side. So 2x equals, so natural log of 5 times 3x. I'm going to write it as 3x natural log of 5. Minus 1 times natural log of 5 is just natural log of 5. So now I have a 2x, I have a 3x natural log of 5 term, and a natural log of 5, which is just a number. How can I get my x's on the same side? You don't want to divide the 3x yet. Nah. We just want to take this one term, this 3x ln 5, and move it to the other side. My goal is to get these x terms together. So if this is a plus 3x ln 5, we want to subtract 3x ln 5. If I subtract 3x ln 5 on one side, subtract it on the other side. So on the left, 2x minus 3x natural log of 5 equals, what remains on the right? Negative natural log of 5. Okay. On the left, I have two different terms. They both have an x. How do I separate that x from them? Kind of divide.
Would it be 3/2 x?
No.
Couldn't divide the natural log of 5.
No, because right now I have x in two terms. What happens if I say factor out the x?
That's what I was thinking, but wouldn't it still leave it at x? Well, I guess there'd be one
Nope.
x. So then
Okay, so what I'm going to say is factor out the x because it's a GCF. Both terms have an x. If I factor out an x from 2x, I'm left with 2 minus 3xl and 5. Factor out the x and we're left with 3l and 5. So now,
Can you take the L and 5 and divide it by the other L and 5?
no. You guys keep wanting to do that. No. Okay, I have x times a quantity equals negative L and 5. If it's x times something, now what am I going to let you do? Divide, but what are we dividing by? That whole thing in parentheses. So we're dividing by 2 minus 3 natural log of 5. Dividing by 2 minus 3 natural log of 5. So, x is going to be equal to whatever I get when I punch in my calculator and get negative natural log of 5 divided by 2 minus 3 natural log of 5. I will say, be careful with your calculators. If you do a fraction bar, that would be best. If you don't do a fraction bar, make sure you put parentheses around your whole denominator. Otherwise, it will not work. So, best is to put a fraction bar, negative ln 5 divided by 2 minus 3 ln 5. And we get an answer? 0.569. It said the other option.
it's like negative 5.63.
Oh, if you don't put parentheses? Okay, yeah. So if I don't use a fraction bar, I'm going to say negative ln 5 divided by parentheses around my whole denominator. 2 minus 3 ln 5. End. Okay, so just kind of a friendly reminder. Your homework is on page 301, 7 through 16, 25 through 28. Give those a good solid try for tomorrow. We will definitely talk about them. I do kind of expect to see a few questions.
A few.
Well, and maybe it'll be better, but.
Emma Conrad, come to